I have a simple physics calculator that works with mechanical motion in 1, 2, and 3 dimensions. Let's start with kinematics, which is one-dimensional motion. So here we have our variables for kinematics: final velocity, initial velocity, time, acceleration, and displacement. The user can select the buttons over here to change these values. So let's say we want to know the acceleration of an object. Let's say this object starts at rest, so 0 meters per second, and after 2 seconds it reaches a final velocity of 4 meters per second. So we're going to go down to the bottom here, we're going to press calculate, and we get 2 meters per second squared. Relatively simple. Let's say the user doesn't know where these equations come from, so they're going to go over here, press for help. Alright, so here we have some simple explanation of the variables, the abbreviations, and what their units are, and then here we derive all the equations that we use. The equations that the program uses are the ones in red. Here, 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 and here. So we can go back and look at projectile motion. We got the same thing. We got some same variables, but we got them in the x direction and the y direction, and then we got the component of the velocity, which is the initial velocity of the x and the initial velocity of the y squared and added together. Then we got the angle, which is the angle from x to y. Right? And 3D motion, same thing. We got initial velocity. We just got z direction. 2 angles here. Right? And let's look at the tutorial for three-dimensional motion. So here we got a graph that's gonna display a projectile moving in 3 dimensions. So we can use these buttons here to set these values. Let's start at 0 here to show. So when this angle 0 is the angle from x to z. Whenever it's launched from here, it's just going to act as a normal projectile in 2 dimensions with x and y, since there's no component in the z direction. So we launch this, we see our projectile move a parabolic path in the x and y direction. Now let's increase this so we see a little more motion. Move this back, set it into space. So now there's going to be a z component, since this is going to, let's set it even 30 degrees. It's going to go back into space. So right now we're still going to leave the wind speed at 0, and we see our projectile go back into space. Right. And let's change the wind speed a little bit. So the wind is going to accelerate the particle in the z direction, because we're going to assume the wind is blowing parallel to the direction of the z-axis. So now let's change these values around a little bit just to see. So if we put this down to 0, although there's no initial component in the z direction, the wind is going to accelerate the particle, still moving it in the z direction. So we see here that started off with nothing, and then the wind accelerated a little bit back. Particle ended up going back into space. Alright, and that's a quick overview of my project. Thanks for watching.